implementing I2C with multiple sensors. For I2C protocol to work, we need master and slave devices. Master can send and receive commands over I2C lines. Every slave has a unique I2C address like 068, 03C, something like this. The I2C address is used to identify and route to which device the data must be read or written. The communication protocol is explained in terms of animation for your quicker reference in front of you. The animation is simple and easy to understand, and you could see that here. It is all about reading or writing to, and all this can be accomplished with ease. Interfacing OLED and MPU 6050. Please make the connections as shown in the figure as well as in the table. This is very simple yet very important to make, and make sure that you connect ATTINY with MPU 50 and OLED appropriately as per the instructions given in the table. It's time for us to code. We will be using TinyOZ OLED and TinyWire libraries for accessing the MPU 6050, OLED and I2C communication between ATTINY85. As discussed in the previous tutorial, thresh neg and thresh pass are used as threshold for detecting step count. Apart from just counting the steps, we will also show the current time using timer functions. As we do not have an RTC, which is nothing but real-time clock, we need to use timer functions. PRES time is used to store the seconds lapsed from the start of the program. Just for a prototype purpose, we declare the present hour and present minute in press hour and press min before uploading the code. Until we power off the ATTINY85, this method shows the correct time. If the ATTINY85 switches off and gets power again, then the time starts again from press hour and press min. The code is presented in front of you for a quicker reference, where you can see that the press hour, press min is clearly declared. Gyro X, Gyro Y and Gyro Z are used for storing all the gyro values. Min Z is used for storing the minimum value of Gyro Z, and Max Z is used for storing the maximum value of Gyro Z in one hand oscillation. Char ARR time of 60 is used for storing the character array of time string, while char ARR steps of 60 is used for storing the character array of step string. POS and NEG variables are used to track the Gyro Z value, and we can understand if the Gyro Z value is above the thresh pass or below the thresh neg. If the Gyro Z value is greater than the thresh pass, then POS is set as true. Similarly, if the Gyro Z value is less than the thresh neg, then negative is set as true. So we use POS and NEG effectively. Steps is a variable used for storing the number of steps walked. In the void setup, initially the OLED setup is performed by setting its mode of display, setting its orientation and clearing any previously available data. Next, the present time is displayed on the OLED. The press R and press min are concatenated and converted to a character array. Also, the number of steps walked is converted to a character array and displayed on the OLED. OCOLED.printString is used for printing a character array on the OLED. The .printString function of OCOLED is clearly explained in the OLED sessions that we have taught you in the intermediate course. We request you to go through the code, and it is self-explanatory and easy to understand as well. The setup of MPU 6050 and the code for extracting the gyro data from MPU 6050 is same as the one that we discussed in the previous session. We obtain the gyro values in all the axes which are stored in Gyro X, Gyro Y and Gyro Z variables. This is the code that we used to find out the minimum and the maximum value among the Gyro Z values in an oscillation, and it's a very simple code and easy to understand. If Gyro Z is less than min Z, then min Z stores the new minimum value. Similarly, if the gyro Z is greater than the max Z, then the max Z stores the maximum value. If the minimum value goes below the thrust neg, then negative is set as true. Similarly, if the maximum value goes above the thrust pass, then the POS is set as true. If both POS and NEG are true, then a step is counted and the same is updated in the OLED display. Also, the POS, NEG, min-Z, max-Z variables are reset. The first if statement seen in front of you is used to determine if 1 minute has elapsed from the start of the program. If 1 minute is completed, then press min is incremented by 1. The second if statement is used to determine if 60 minutes has elapsed from the start of the program. If 60 minutes get elapsed, then press R is incremented by 1 and press min is reset to 0. Similarly, the third if statement is used to determine whether 24 hours has elapsed from the start of the program. If 24 hours got elapsed, then press R and press min are reset to 00. This is all very simple and easy to understand. Why do we do it? Kindly note that this method is used to just show you that you can display the time along with the number of steps walked on an OLED. But this method is not at all advisable for real-time applications. Instead, you can use a dedicated RTC module which can count the time even when the ATTiny is switched off. This is for a demo purpose and to understand how things work. Let's summarize. We have seen the procedure for building a pedometer whose values will be displayed on an OLED using ATTiny85. The entire system is low power based and is portable as well. It requires very minimal number of components. The same procedure can be followed to make different kind of counting applications. For example, you can make a device to count the number of pull-ups done by a person, number of weight lifting attempts done by a person. All these are simple exercises that you can try it out by yourself. Building these kind of real-time applications is really very simple. You need sequence of data for few seconds to analyze and to determine the pattern and the algorithm. An RTC module is highly recommended if you want to display the time in real-time projects, because hard coding of time will not work properly if the module gets reset or gets any power interruption. Hence, it is always advisable to use dedicated hardware for timing. In this session, we are going to understand how do we build a simple pedometer to count the number of steps. It is simple and please follow the guidelines as we are presenting you. First, we need to upload the code to ATTiny85. Go to the Arduino IDE and we need to follow certain sequences. We need to make the connections in parallel for everything to be done, and we have connected Arduino Uno plus ATTiny85 as prescribed in the connection diagrams during the theoretical explanation. Make sure the connections are done properly, without which the system won't work. Now go to File, go to Examples, Arduino ISP, go to Tools, Board, select appropriate board there, which is nothing but Arduino Uno. And go to Tools again, see if COM port is all proper and upload it. This will help you in getting things done as a programmer. And once the uploading is done, we are free to go to the next step. The uploading is now complete, and once it is done, close that window, and we can now take up the file pedometer which we have written. From that, go to Tools, select the ATTiny microcontrollers. Make sure you have selected the processor properly, the clock internal frequency and the port. Also, programmer Arduino as ISP must be selected. Upload the code, and once the uploading is done, we are all set to go to see the demo. It is all simple and efficient provided you follow the guidelines precisely. Done uploading has come. Now we can demonstrate the product. You can see that we have connected the ATTiny85 to OLED and MPU 6050 and visualized it as a wearable by wearing it in hand. You can see the time as 1947 and number of steps walked is 0. We are going to walk right now and we will see if there is a change in steps which is reflected in the display. We are going to walk along the corridor and it should ideally change the number of steps walked and it should be displayed immediately for your reference. I am walking along the corridor and once my walking is complete, you could see that the number of steps would be updated and we will have the correct count displayed on the OLED screen. Have a look and you could have a number as 9 and the time is also updated as 1948. Earlier it was 1947. That is it, we have built a very simple pedometer and it can track the time as well as the steps. Since it is for prototyping and proof of concept purpose, we built it with a bigger breadboard, but obviously when you want to make it a product, it will become smaller with more smaller components.